Let's review molecules and some of their properties, including molecular shape, polarity, and electronic structure. Valence shell electron pair repulsion theory, or Vesper theory, tells us that electron groups minimize energy by orienting themselves with the maximum possible angle. That is, they try to separate themselves as much as possible. This makes sense because electrons are negatively charged, and like charges repel. So what constitutes one electron group? An electron group can be a lone pair, a single bond, a double bond, a triple bond, or a lone electron called a radical. Any one of these counts as one electron group, according to Vesper theory, despite the fact that a lone pair and a single bond are 2 electrons, a double bond is 4 electrons, a triple bond is 6, and a radical is only 1. What's really going on here is that we care about the sigma electron groups. And all of these occupy a sigma orbital. A lone pair goes in a sigma orbital. Single bonds are always sigma. A double bond contains a sigma bond and a pi bond, but we only care about the sigma bond in terms of Vesper theory. A triple bond contains a sigma bond and 2 pi bonds, but again, only the sigma counts in terms of Vesper theory. And then the radical will also occupy a sigma bond. So electron group geometry, and therefore molecular shape, are dictated by the number of sigma orbitals on the central atom. So the number of groups can be 2, 3, or 4 for organic chemistry. For 2, your electron geometry is linear, with a 180-degree angle between those 2 electron groups. If you have 3 electron groups, it's trigonal planar, with a 120-degree angle. That is 3 electron groups pointing to the corners of an equilateral triangle. And if it has 4 electron groups, it's tetrahedral, with a bond angle of 109.5 degrees. Molecular shapes are derived from the electron geometry. So if your electron geometry is linear, your molecular shape will always be linear. On the other hand, if your molecular shape is trigonal planar and you have 0 lone pairs, then your molecular shape is trigonal planar, trig-plan for short. If you have a trigonal planar electron geometry and 1 lone pair, then you have what's called a bent molecular shape. If you have a tetrahedral electron geometry and 0 lone pairs, that is a tetrahedral molecule. If you have 1 lone pair in tetrahedral geometry, that's a trigonal pyramidal a molecular shape. And if you have 2 lone pairs, that is bent again, although it's got a different bond angle. So you'll see tetrahedral when you have a carbon with 4 bonds, or a nitrogen with 4 bonds. And if the nitrogen has 4 bonds, it'll be an ammonium cation. That is, it'll have a +1 charge. You'll see trigonal pyramidal if you have a carbanion. That's a carbon with 3 single bonds and a lone pair. You can also see it with a neutral nitrogen, 3 single bonds and a lone pair. Bent, you'll see with an oxygen that has 2 single bonds and 2 lone pairs. You can also see bent when you have a nitrogen that has a double bond and a single bond and a lone pair. Trigonal planar you will see when you have a carbocation. That's 3 single bonds and no lone pairs. Linear you'll see when you have a carbon that has a triple bond and a single bond.